Welcome to this explainer. Today, we are diving into what experts are actually predicting could be the next multi-billion or even trillion-dollar supercycle. For decades, industries like theoretical physics, commercial aviation, and government defense have all pretty much operated in their own distinct silos. But today, artificial intelligence is absolutely shattering those walls. We are witnessing a massive new wave of aerospace innovation driven by the convergence of these highly specialized fields, and it's going to completely change how we all fly in the future.
To really grasp how these worlds are colliding, just consider the story of Sabrina Gonzalez Pasterski. She's a renowned theoretical physicist at the Perimeter Institute, and she explains her entry point into the aerospace and defense world like this. She said, "The closest thing I have to private aviation was being a kid flying in a Cessna 150 over nuclear power plants with a Geiger counter." It's a bizarre but totally fascinating story, right? As a 12-year-old, she was essentially running her own science experiments, pitching the idea that tiny planes could fly around and detect if someone was doing something bad. It brilliantly illustrates the unexpected and highly organic link between raw scientific curiosity, theoretical physics, and the real-world practical applications of aviation.
Okay, let's dive right into this convergence arc and map out exactly how we'll unpack these intersecting industries today. First, we'll look at the aerospace supercycle. Second, democratizing AI and R&D. Third, bridging academia and industry. And fourth, the unmanned flying future.
Starting off with Section 1, the aerospace supercycle. The future of flight is definitely no longer being developed in a vacuum.
The days of isolated engineering are completely behind us. We've entered what we call the innovation triad. Just think about the players involved here. You've got a cutting-edge theoretical physicist, a commercial aviation CEO from Bombardier, and a defense contractor CEO from Sierra Nevada Corporation. On paper, these three seem completely disconnected. You have a researcher looking at fundamental distances in physics, a company building commercial jets, and a contractor building defense tech. But AI is the gravity pulling them all together. Executives used to just integrate subfields from within their own industries. Now, the real game-changing innovations are coming from entirely outside their traditional fields.
Moving right along to Section 2, democratizing AI and R&D. Let's look at how lower-cost research is changing the game.
And this brilliantly illustrates the dramatic shift we're seeing on the ground level. Traditionally, R&D in aerospace required massive funding, enormous teams, and the construction of physical testing rigs. You literally had to physically build something, which took months and months just to see if an idea even worked. But today, we've entered a new AI era of lean, low-cost R&D. An individual researcher can now handle their own data science coding, spin up virtual simulations, and see if a concept works before ever trying to scale it. This level of access was previously unthinkable.
So why is this happening right now? Well, as Sabrina pointed out in our source panel, one of the most exciting aspects of this shift isn't just about semantic search, it's about the physics itself. Individual researchers can now code their own tests because, as she notes, the laws of nature are highly compressed. Because of this, modern AI numerical models work incredibly well for super complex tasks, like fluid dynamics computation. You no longer need the massive financial backing of a giant corporation just to test how air flows over a newly designed wing. You can simulate the whole shebang virtually and highly accurately with AI.
That brings us to Section 3, bridging academia and industry. We need to talk about funding frameworks.
For all this brilliant AI research to actually survive and scale, it needs funding for what's called blue sky research. This is scientific exploration driven purely by curiosity, without an immediate, obvious commercial application. It's high risk, high reward. A perfect example of fueling this is the incredible $100 million donation made by the founder of BlackBerry to a Canadian theoretical physics institute. It perfectly highlights the massive private bets being placed on blue sky thinking. It's a really fascinating public-private partnership model. By combining this kind of philanthropic giving with government partnerships, that sheer entrepreneurial drive gets stabilized by large-scale funding.
Let's walk through how this builds into the ultimate partnership blueprint. Academia brings those blue sky ideas and deep expertise. Industry and entrepreneurs bring the business case application. And the government? They provide the large-scale funding and immediate defense needs. Now, the traditional pipeline used to be industry coming to universities to find experts. But the new, highly disruptive model actually flips the script. Academics are now the ones who need to bring in entrepreneurs as consultants. Since researchers often aren't trained to think about the business case, directly consulting with entrepreneurs allows these different disciplines to work together and uncover the commercial tech applications hidden right inside fundamental research.
Finally, let's head into Section 4, the unmanned flying future, looking closely at concrete aerospace applications.
We're now shifting our focus to the concrete applications of this fast-paced R&D. In the defense sector, we're seeing massive transformation. Modern conflicts like the war in Ukraine have demonstrated a critical need for constant technological iteration, particularly with drones. As our source material highlights, government contract structures are fundamentally shifting. Governments can't just place an order for 100 drones over a 5-year period and walk away anymore. The technology just moves way too fast. They require a constant conversation about updating strategies and capabilities. So to meet this demand, companies like Bombardier are leveraging thousands of engineers and PhDs. But more importantly, they're using virtual AI simulations to replace physical test rigs, allowing them to rapidly develop and deploy solutions faster than ever before in history.
Now, what's really interesting is this mental picture. Imagine a traditional manned F-35 fighter jet, but flying in tandem with it on either side are faster, unmanned, AI-driven drones. Aviation leaders like those at Bombardier and Sierra Nevada Corporation see this AI wingman concept as the immediate future. They're taking their core skills in aerospace and applying them to develop a new generation of drones that can fly faster, follow complex formations, and carry much heavier payloads, all integrated seamlessly by artificial intelligence.
So what exactly is the roadmap for pilotless aircraft? Well, the executives in our source material lay out a very clear pipeline. Step 1 is the military application, unmanned airplanes and AI wingmen. We know the technology exists today. Step 2 involves taking that technology and overcoming the immense safety and certification hurdles required for the civilian world. And that inevitably leads to Step 3, unmanned commercial flights. While commercial aviation is obviously far more complicated due to strict safety authorizations, the technological foundation is being cemented right now in the defense sector, meaning your future commercial flight might just be piloted by a computer. Crazy, right?
Which brings us to a provocative final thought directly from the panel. Will AI and aerospace innovation ultimately push these commercial and defense companies into space? When asked if they'll eventually end up in space, the industry leaders noted that while it might not be in the immediate plan today, they're constantly evaluating where their core skills can contribute. As they perfect ultra-fast, high-payload AI drones and push the limits of numerical fluid dynamics, the stars really are the inevitable next frontier. The aerospace supercycle is here, and AI is absolutely the engine driving it. Thank you so much for joining me for this explainer, and I hope this gave you a powerful framework for understanding exactly how these incredible industries are converging to reshape our world.